Putting it all together. From Earth, without ever leaving the planet, it appears that the Earth is flat, and when you walk all the way around it, your feet never leave the ground and start walking on the ceiling for half of the trip. So it appears to you to be horizontally in front of you forever. But if you leave the planet and go hang out on the moon for a while, and you watch your friend walk around the planet, you see him walking around a ball, like a bug on a basketball. Likewise, up close, i.e., locally, all experiments of light are in a flat spacetime, and it's at its universal constant velocity, moving in a straight line. If you get a global picture, however, things start to become a little more complex. Given that we are doing our experiments on Earth in relatively tiny observatories, we cannot see the curve, just the final results, which appears to us as to have arrived in straight lines. Mathematically, then, we need to include a thing which prevents us from forgetting that the universe is not entirely flat, which will keep our lengths accurate to reality. The mathematics required to move between flat and curved spacetime are tensors, which is not something we are going to get into. All that needs to be said here is that a new metric was formulated which captures all of the geometric and causal structures of the space-time ether, meaning that it can be used to define notions of time, space, distance, volume, curvature, angle, and temporal separation. Einstein required using this new form of mathematics in order to better describe the universe. Starting then from the very beginning, if you are a mass, then that means you are composed of atoms or pure energy. We are made of atoms. Atoms are just regions of the ether which are stable and bound tightly in a tiny space which cannot be occupied by different energies of the same kind, in the same time and in the same respect. The stability of the atom is caused by atomic forces which interact and change, and this means everything with mass also has frequency and therefore is also a clock. All masses are thus their own type of clock, which always interact at the speed of causality. The speed of the ether interacting with itself is what allows for that stability of the atom, of that mass, of that clock. Now your atoms send that energy around through the use of photons. Photons always travel at a constant velocity c, in vacuum. If an atom in your foot shoots out a photon that is absorbed by an atom in your head, and you are in a box, and that box is said to be motionless, as you are not moving while it is on the surface of Earth, then you know that the length the photon traveled was your height. And given your height and the constant velocity of light, you can calculate the time duration. If, however, your box is an empty space moving upward at a constant velocity near the speed of light, then the photon from your foot atom will still be traveling at a constant velocity c, and will still pass you by at c. If you think about how this could be, it is only possible if the photon from your foot was traveling for a longer amount of distance, the distance to the original place of your head, plus the distance moved at the box's velocity. And if the clocks of your foot atom and your head atom are synchronized, such that to an atom in your torso, it receives the photons of the foot and head at the same time, meaning that the foot photon clock is ahead of schedule, and the head clock is behind schedule, such that the longer distance of the foot photon matches the clock of the shorter distance of the head photon. The torso runs into the head and runs away from the foot. Thus, to be seen at the same time requires different set times. If, however, your box is an empty space moving upward at a constant acceleration, acceleration is an absolute state of motion, and everyone inside and outside of the accelerating frame knows which frame is accelerating and by how much. For example, if you have 4 boxes moving in space, one is with us. We are considering a stationary rest frame. 2 are moving at a constant velocity, one moving from below us to above us, the other moving from our right to our left, and one is accelerating. The effect of relativity is that we cannot tell the difference between a motionless frame, like ours, and a moving at a constant velocity frame, like boxes 2 and 3. And so, when we see our accelerometer, it is a box with a ball in the middle, held in place by springs. When we look at the accelerometers of one of the other velocity frames, those balls are also in the middle of their boxes, despite us seeing them moving and expecting a little tension on the springs in the motion of that direction. Comparatively, when we look at the frame that is accelerating, we all see, including the people in that frame, that the accelerometer is stretching the spring at the top and compressing the spring at the bottom, and curving the springs at the sides. That is the sign of acceleration. And using Hooke's spring equation, we can calculate the force applied to the springs by measuring their new lengths. From all perspectives, then, we know that if you are accelerating upwards in your box when your foot photon sends its signal up to your head, then your foot atom, which has a mass, would lose energy, as we had seen in Einstein's last 1905 paper. By those same acceleration and special relativity ideas, the photon itself loses energy as it races to catch up with your head. After each second of the atom's clock, we imagine a new velocity frame of reference, which is changed drastically by the next time unit. But as photons cannot lose velocity, the loss of energy is within the photon's wavelength. And the wavelength stretches into the red part of the visible light spectrum, which is why we call it redshift. So long as you are in a uniform field of acceleration, the photons from your foot are going to lose energy when they reach your head, if it has the energy left to be seen. And as Einstein showed in the photoelectric effect, a photon with the wrong quanta of energy cannot excite the atom of the receiver. In the reverse manner, the atom in your foot would be receiving the photon with more energy, and the clock is moving much faster than theirs. This is different from constant velocity frames, where each observer sees the other experiencing the same phenomenon. E.g., in the constant velocity setup, if Alice sees Bob's clock as slow, then Bob sees Alice's clock as slow. But here in the accelerating frames, if Alice sees Bob's clock as slow, then Bob sees Alice's clock as fast. We can detect acceleration. Finally, if we cannot tell the difference between a uniform constant acceleration field frame and a uniform gravitational field frame, then special relativity holds for both. And therefore, a uniform gravitational field is equivalent to a uniform constant acceleration field. We know, however, that the gravitational field of Earth is not itself an accelerating frame of reference. For, say if the Earth were flat and accelerating upward at 9.8 meters per second squared, it would only take a relatively short time for the Earth to surpass the speed of light and continue accelerating past the speed of light, in which case nothing in the universe could ever causally interact, in which case we could not be having this conversation. Therefore, we are in a gravitational field, not an accelerating frame. And therefore, clocks on the ground of Earth tick slower than clocks at the top of a skyscraper. The equivalent principle therefore now states that a frame of reference experiencing a non-rotating free fall occupying a small region of spacetime, the laws of physics are those of the special theory of relativity. The fact that we do not live in a uniform gravitational field in a global sense. Just from large scales, it is clear that to the people in America versus the people in Australia, up and down are, relatively speaking, in opposite directions. And this is true too for people in Ecuador versus people in Indonesia, which are not the exact same ups and downs as they were for the last two. The Earth is a sphere, kinda, so the downward field lines point radially inwards. And the acceleration you experience on the ground is coming from the ground pressing up against you. Mass is a kind of energy. Regardless of its size, a mass is composed of energy stuff, which can release and absorb energy. The fact that the universe is not entirely dark, the fact that there are stars, is proof that the plain light waves of energy from billions of stars are passing by you at every moment. And so it is safe to assume that if you can see that starlight, that your atoms, your mass, can absorb starlight, and therefore you were struck by a tiny amount of that star's mass, which is converted into momentum, which would cause your atoms to recoil a bit when receiving them. Therefore, you experienced a force. Therefore, you experienced a moment of acceleration. So two masses floating near each other in empty space will be experiencing tiny accelerations from photon momentum, and therefore also re-release that energy with tiny acceleration. Therefore, clocks closer to them tick slower than clocks further away. So everything with mass also has its own gravity, which we can express as meaning anything with mass interacts with the ether in such a way that time dilation bubbles around it. If you were to draw this as a Cartesian coordinate system, accounting for special relativity, you would create a world-line space-time diagram. And the fact that these mass time dilation bubbles exist maps onto the graph by making the appearance of curving lines, either in the motion of the accelerating object or in the fabric of the graph itself, combining together the fact of the gravitational time dilation bubbles around masses with a conceptual framework which is currently available to our 2 to 3-dimensional graphing language. One can show for a fact that gravity, the falling downness, is not itself a force, as it is identical to not experiencing a force at all in empty space. Anything that is equivalent to floating in space with not a single object or force field around it for billions of miles can be said to be caused by force. So falling down, the effect of gravity, is not a force. All we currently have, conceptually speaking, is analogous to curvature, to the markings of a line on a space-time diagram. And therefore objects which naturally move at constant velocities experience a change in time when they pass by a time dilation bubble. And due to the consequence of special relativity, the object never experiences a change in time, but rather that change is expressed as a change in space, and the object falls down. Therefore, for all intents and purposes, we conclude that gravity should be considered, in the conventional sense, the manifestation of a curvature of the space-time ether, which itself is induced due to the presence of matter. This is the central tenet of the general principle of relativity. This video is possible thanks to contributions to the Existence University Patreon by viewers like you. Thank you.